Unit 5, Similarity, Lesson 6, Scale Drawings and Models. Your objectives for this lesson are to determine the scale of a model or drawing and to use scale factor, ratios, and proportions to solve problems related to scale models and drawings. Okay, so a scale model or scale drawing is an object or drawing with lengths proportional to the object it represents. Examples of these would be blueprints of a house, or if you had like a model car that you built. Those are examples. The scale of a model or drawing is the ratio of the length of the model or drawing to the actual length of the object being modeled or drawn. So model or drawing comes first, or would be the top part of the fraction, and the actual object would be the second number or the denominator of the fraction. The scale factor is written as a unitless ratio in simplest form. You saw this in the last lesson, simplest form. Scale factors are always written so that the model length and the ratio comes first, which is what I just said on the last page. Example 1. The scale on the map shown is 0.75 inches to 6 miles. Find the actual distance from Pineham to Menlo Fields. So this 0.75 inches to 6 miles, you could write that as a fraction like this, 0.75 inches to 6 miles. Now, of course, we just said scale factor is a unitless ratio, and I have 2 units here. So, we're going to have to probably write a proportion here. And we're going from Pineham, which is here, to Menlo Fields, down here. So what I'm going to do is actually measure that distance. So where's my ruler? Oh, it's up at the top. And I got 2 of them. Awesome. Okay, so let's bring one of these rulers down here. We're using inches because the scale says inches. Okay. And lining these up. Okay, so I'm getting that this is about 2 1/8 inches, and 1/8 is 0.125. So I'm going to say this is 2.125 inches. Okay, so I'm going to use this here and say this equals 2.125 inches over x. We're looking for the number of miles that corresponds to that. And now we can cross multiply, and we get 6 times 2.125 divided by 0.75 equals x. And you may be saying to yourself, what about the units? Well, technically you could have multiplied with units here and said inches times miles, and then this would be inches times miles. But ultimately the units do cancel. Since we have inches on top for both of these and we want miles on the bottom for both, the units don't matter because they match top and bottom. If they didn't match top and bottom, then we'd have an issue. But they do, so we don't. So 6 times 2.125 is 12.75. Divide by 0.75 and we get 17. So x is 17 miles Do not forget that unit in the last step. So from Pineham to Menlo Fields, we are going 17 miles. Example 2. A dollhouse that is 15 inches tall is a scale model of a real house with a height of, 20 feet. What is the scale of the model? So we're saying 15 for the model to 20. So 15 inches to 20 feet. But we can simplify this. So 15 and 20 both have a factor of 5. So if I take 5 out of 15, I'm left with 3. 5 out of 20, I'm left with 4. So I can write this to 3 inches to 4 feet. Or I could write it as 3 inches to 4 feet. But do keep that 3 inches first. So the model always goes first. Okay. How many times as tall as the actual house is the model? And basically what we're being asked for here is the scale factor. We want to know the scale factor, which was a unitless ratio. So we need to get rid of our units. Right now we have 3 inches for every 4 feet. Well, I know I can convert feet to inches very easily. So if I have 1 foot, I will have 12 inches. And when I multiply these top and bottom, you know, if you have the same thing, top and bottom, they cancel. So the feet cancel and the inches cancel. So put it opposite so that they cancel. You don't want inches squared over feet squared. And if we multiply this straight across, we get 3 over 4 times 12 is 48. Now this simplifies to 1/16. So this is our scale factor, which means the model is 1/16 times as tall as the actual house. This is also the scale factor. Yep. And that is the end of lesson 6.